This week, the Planet Mechanics are battling to conjure up electricity out of thin air. They must make England's most remote youth hostel completely energy self-sufficient. But with the forces of nature raging against them and two very different angles of attack, will our eco-warriors get the upper hand? Or be knocked out in the first round?
Oh, I don't like it. I love doing these in the wet.
Dick Strawbridge is an ex-army officer turned eco-warrior.
Oh!
Jem Stansfield is an inventor with a wild green streak.
Whoa!
Two men on a mission to fix the world.
Whoa!
One mechanical solution at a time.
Oh.
Together, they are the Planet Mechanics. The English Lake District, immortalized in verse by William Wordsworth. But the poet simply wouldn't recognize broad swathes of his beloved fells if he walked them today. Over the past 100 years, vast forests of non-native conifers have been planted. Here in Ennerdale, there's a radical project underway to rip out the rows of regimented pines and restore this valley to its natural glory. Lovers of the lakes are delighted, but there is one unfortunate casualty. England's most isolated youth hostel relies on this rundown forestry road to bring in all its power supplies. But once the forest goes, the service road will be abandoned. And to survive, Blacksail Hostel must generate its own power. That's where the Planet Mechanics come in. They're heading up to Ennerdale Valley to see what can be done. Can Dick and Jem make Blacksail Hut energy self-sufficient and save it for the thousands of hikers it serves each year?
At the moment, they've got a generator for electricity, and they have to have all their fuel delivered from the generator down this road.
But this road's going. The whole idea is that Ennerdale goes back to nature. And, you know, so people walking along here, the road goes, there is no way of getting stuff in. That means they have to really survive completely self-sufficiently.
I think we've put ourselves in quite a tricky position, telling these guys that we're going to come up with a solution for them that's going to power their hostel.
They're taking their faithful old mobile workshop. Normally happy as cruising down hills, it's struggling on the steep road up to Blacksail. After steadily climbing the 6.4 kilometers along the already deteriorating forestry road, Dick and Jem finally get their first glimpse of the hostel.
This is remote, mate.
I know, but then there's nobody to actually get anything from. We don't have it in the truck. We just don't have it.
For the next few days, they'll be working with hostel manager Tony Hume.
Where do you get your services at the moment? Like water, electricity, gas?
Right, the water is here. We have water supply. But everything else has to be brought in on the forest road.
And if the road stops being maintained, it could get washed away any time, couldn't
Tomorrow.
it? Tomorrow? It is that serious?
Well, you know, we get heavy rain, it could wash out the gully.
So what happens to the youth hostel?
No power at all, no cooking facility, no heating, and the question has to be asked whether you have a hostel here at all.
What happens to your job if this goes?
My job would change.
See, my empathy for walkers is one thing, but for people's jobs, I am bothered. I like you. I'd like you to keep your job.
Excellent.
In a nutshell, the road goes, that means you end up with no electricity, no heating.
Yeah.
That's not a great thing to advertise.
But before Dick and Jem can even begin to start figuring out how to rescue Blacksail and Tony's job,
Lights and sockets.
they need to carry out an energy audit to figure out exactly how much power the hostel is currently using.
2 radiators.
A tiny room.
It's on.
It's on. What is it?
August.
Middle of August.
And it's on. It says it on your watch, does it?
I have to check.
The generator's down this end somewhere.
4,000, that's a 4 kilowatt generator, I guess.
Yep. And the solar panels are around here somewhere, aren't they?
There they are, though.
And yeah.
But tucked around the back of the hostel, there's a nasty surprise in store.
15 gas bottles. These lot must be directly for heating, water heating, that kind of thing.
That's obviously where the most of their energy goes.
These gas bottles are Black Sail's dirty and not so little energy secret, and are giving Dick and Jem a bigger headache than they'd bargained for. With just 3 solar panels generating a tiny amount of power, the hostel relies primarily on heavy gas cylinders to supply heating, cooking, fuel and electricity. And when the road goes, the gas goes.
OK, isn't that place up there called Windy Gap?
Yeah.
Which makes me think there's got to be wind. It doesn't get that nickname ironically.
Yeah.
So in which case, what about a wind turbine? I mean, a wind turbine, you get a lot of power out of those.
OK, so that's a possibility. What about solar?
You're joking. I've barely seen the sun since I've been here, and 1,000 watts of solar power is a lot.
OK, well, what else have we got? They got the water, they got streams.
They've got, I mean, that's almost a waterfall up there. It's a long way away, but it's almost a waterfall.
I can hardly see it.
You can see it enough to know that that's falling water.
Yeah, good. Yeah, no, water power's good, but we have to think about what else we can do.
All right, then. It seems like it's wind and water.
Having agreed that wind and water are the most promising elements in this inhospitable landscape, it's time for a reconnaissance mission.
I'll tell you what, we have to go and have a look around the place. You're going to test for how much wind you've got in good places. I'll go and find out where the water is.
All right.
Oh, whoa, whoa, steady, steady. Let me know how you get on.
Okay.
So the battle lines are drawn. Eco-warriors Jem and Dick must try and figure out how to squeeze maximum power from the elements around them.
I wonder how much the contours affect it.
Jem uses his anemometer
Well, that's pretty much nothing.
to measure wind speed in a series of promising locations, while Dick measures the water flow in the River Lisa, which runs down the valley,
400 litres a second.
to see if the current could be powerful enough to produce, well, current.
You can see why they have tall masts on wind turbines.
But there's not enough water and not enough wind down in the valley.
It's like onwards and upwards.
There's no alternative, so Dick and Jem are forced to scramble even further up the mountain. Ex-Colonel Dick follows the course of a stream, sailback, while Jim heads in the direction of Windy Gap.
Feel the extra wind up here.
And after climbing several hundred meters, Dick's persistence finally pays off.
Jem, it's Dick, mate. Get your butt up here. It's brilliant.
On my way. Oh! Dick! You struck gold here.
Look how much water we've got. And what about the drop?
This is zipping with energy. I love it.
The only thing is, how are we going to pipe this down to the bottom? How about the wind?
Not great, Dick. It swirls everywhere in this valley. I've been up, down, around, and it's like you get a few knots here, no knots there. Probably our best bet is to use a kind of funnel effect in the middle, but chuck the mast way up high. But then that's a horrible compromise, because the higher it goes, the uglier it is.
They're not trivial problems, you know.
Dick's found a reliable power source, but it's miles from where it's needed. Jem wants to harness the swirling wind, but getting a grip on it could be tricky. Having never built a wind turbine before, Jem needs to figure it out on a smaller scale first.
Grab that. Obviously, you don't normally need one of those for a wind turbine. Connect those up.
That's not a wind turbine, you know that?
So electricity in, wind coming out, OK?
You know that's wrong, don't you?
Yeah, but here's the bit I do like. Take this bulb.
A normal fan's blades spin because it's powered by an electrical current. But Jem's idea is the reverse. He's going to harness a fan's spinning action to produce the current, which is exactly like the manufactured turbine already on the roof.
When I put wind in, it's going to turn the motor, then the motor will generate electricity, and you will be almost blinded. You ready?
Yep. OK.
That's all there is to it.
But if only it were that easy. Jem's challenge will be to build from scratch blades, the electrical generator and tail fin, all from what's at hand.
The components, the materials you're going to use, what are you going to do the blades with?
I can't see me carving metal.
Yeah.
And, you know, we haven't got plastic moulding facilities. I'm going to have to carve the blades out of wood. So I'm going to end up with wooden blades on it. All right. And then they're going to come down, and then I'm going to have to make some kind of generator on the back of it, and then that's all going to have to be mounted with a tail to keep it going into the wind there, and able to swivel on a bearing at the top there.
So we know what we're going for: blades, generator, tail, mast, location.
Yeah.
Jem will make 3 blades which are attached to a handmade generator. In the generator, there is an arrangement of magnets and wire coils. When the blades are turned, the magnets spin past the coils and an electrical field is generated. But Dick still has some serious concerns regarding safety. An out-of-control spinning turbine blade could cause hiker chaos in Ennerdale.
It's got to be balanced and it's got to be well done. Otherwise, never mind wild Ennerdale, they'd be livid. There are problems, even with professionally made wind turbines. If it gets to high wind, they can fling a blade and they can go hundreds of meters.
So while Jem goes back to the drawing board to make sure no one could get injured,
That looks like it.
Dick's much more confident that water dropping from a great height has potential to generate huge amounts of power. All he has to do is prove it.
Not everybody's convinced about the power of water. Do you reckon if I managed to lift you using a hot water bottle and a hose with a little bit of water in it, they'd be impressed?
I would be.
Go on, stand on that.
Go on, then.
Right. You see, what is this?
Even with a tiny change of height from the water reservoir, the increase in pressure into the hot water bottle is startling.
Yeah.
And he's up in the air.
I love it.
And that's just, what, a couple of metres of water, 3 metres of water. Can you imagine what 80 metres coming down that mountain's going to do to our turbine?
80 metres is going to be quite awesome.
Once the water has dropped 80 vertical meters from Sailbeck down to the River Leaser, there could be a tremendous amount of potential energy on tap. And if Jem finds the swirling wind in the valley difficult to harness, Dick could easily have the upper hand.
Where we were on the top of the hill, yeah, we've got at least 80 metres, possibly 90 metres to the bottom where we can put a water turbine. You can think of it as a little water wheel, I suppose, yeah? But if we've got sort of blades going around and have the flow of water coming in and going out, we've got a chance to rotate this thing really, really quickly. Now, attaching that on to, similar to you, a generator, that is going to make electricity.
One of us is going to have to build a generator because we have only got a generator.
Paper, scissors, stone.
OK, then.
1, 2, 3. I won.
Ow!
Yes, that's 1-0 to me.
I'm glad you didn't hit me with a stone. I'm pleased I got the paper there.
Dick has a head start over Jem. He can use an old spare generator stored in the back of the truck. But he still has the huge problem of finding a way to get the generator spinning using water power. Dick plans to tap a reservoir of water high up a mountain and pipe it a distance of 750 meters to the River Leaser. He will then fire it at high pressure over a miniature water wheel called a cross-flow water turbine. And this will turn the generator, which in turn creates electrical energy. With Dick and Jem confident that they're on the right track, all they have to do now is win over Tony.
Water is the big thing here, yeah? Because we've been up at the beck on the other side. It's Sailbeck.
Sailbeck,
yeah. The stream, yeah? Masses of water. And using that water there to probably provide all the power you need here for heating and for lighting.
We've got to lay about, what do you reckon, Dick? Quarter mile, half mile of pipe?
Easily a quarter mile of pipe. But we don't have piping in our horse box. That's funny, really, isn't it?
What sort of pipe?
It's got to take the pressure. I can't under-stress this. The other issue is, would it be possible if you could track down quad bikes, something like that, that we can actually cart them up on?
To drive across a site of special scientific interest?
No, OK.
No,
Right.
It's not really what we're trying to do here.
Tony's concerned that to get the water turbine plan up and running will involve piping large quantities of water right across a protected nature reserve.
I'm worried about our total reliance on water. So what I was thinking is, if we have a wind turbine, now, I can see your eyebrows raised because they have a reputation for not looking so good.
Tony's also worried that a wind turbine will be a blot on the landscape.
We'll build it. You can make a judgment on it once it's there and you look at it.
It is going to be quite big. Let's not sort of underestimate this. It's going to be a decent-sized turbine. But today, people are starting getting around to the fact that when you have a wind turbine, it means you're trying to be green, you're trying to do something.
Yeah, I
it's
appreciate
probably going to
that,
be
yes.
more and more acceptable over time.
Dick and Jem have drawn up two very different battle plans, both with serious strategic drawbacks. So, wasting no time, Tony heads off to see what favours he can call in, leaving Dick and Jem to press ahead with the construction. First off, the wind turbine blades. With each of them needing to be just over 1 metre long, equally balanced, perfectly aerodynamic and identical, Jem has no margin for error. By cutting out a series of triangles, Jem will arrive at a wedge shape before starting to work it into an aerodynamic blade. Knowing that he's only got a few days to build the whole turbine, and with no two sides of each blade the same, Jem cracks on at an impressive speed. The key component of Dick's water turbine will be a steel runner, or mini water wheel. This will consist of two circular discs which will sandwich several steel slats, or fins. Because time is short and cutting through steel so labour-intensive, Dick's measurements must be ultra-precise. Any mistakes here will have to be corrected later, so speed and concentration are key. Each of Jem's blades has to be shaped so that the flat edge at its base catches the wind, allowing the whole thing to overcome inertia and start its spin, like the turbine on the horsebox roof. Added to which, each of the 3 blades needs to be exactly the same as the other 2. Not easy. After sanding down, each one is finished with a weatherproof coat of varnish. Having marked up and cut out the 2 sides of his water runner, Dick needs to make sure that he's got perfectly smooth discs.
Hey, that's quite circular.
He now has to cut a series of notches into each steel disc into which the runner's fins will slot.
Jem, have a look at this little bad boy. This is one side of the turbine. I've got little sections of pipe. They're going to be the blades, and we stick them between the 2, and that is all we need. That's the turbine, mate.
That's really nice. It's
quite
like
tiny.
some ninja throwing star. But check this.
It's really complicated shapes, isn't it?
That's a bit of an understatement. I can honestly say I ache from concentrating, from being desperate not to mess it up.
How did you join them together?
Right, that's glued and screwed to the back plate. Then this front plate gets glued and screwed on, so that's one solid wooden item.
Yeah.
Then that gets bolted onto the magnet plate. Then that makes the magnet spin past the coils and electricity is generated. Everybody's happy.
Lots of glue and lots of concentration. Fill your boots, mate. I'm going to go and weld.
With the side discs of the water runner now notched, Dick can finally fit all the fins and start welding it all together. With the wind turbine blades now complete, Jem just needs to fix on a final wooden disc, onto which he'll eventually attach his spinning electrical generator.
It looks like I've got something right, okay? When the wind catches these,
Way to go! That's impressive, mate.
there's a load of friction on that at the moment because it's just on that rod, but that spins so nicely.
That's going to be excellent.
Oh, it's picking up, it's picking up.
Oh, I've got to go get back to mine now.
I've got to
Show
figure a
off.
way of stopping it. If I take off, Dick, come and get me.
While Dick feels certain his water turbine is a solution to the hostel's power needs, he hasn't yet got a suitable way of piping the water 750 metres all the way down from Sailbeck to the water turbine at the bottom of the valley. Meanwhile, Tony is trying to persuade the Forestry Commission's fire department to loan out some of their hoses. While Dick waits anxiously for an answer, Jem has raced ahead and started work on his generator. But how exactly will it generate electricity?
So when the wind blows, the blades spin round. When the blades spin round, they spin here, which is going to be my generator. That's going to generate the electricity that's going to power the hostel. Okay so far?
Absolutely.
Good, because this is the bit I'm really worried about. This is the next part of the plan. I'm going to have 2 discs, and on these discs, I'm going to sit 8 magnets. The magnets are going to face each other so that it concentrates the magnetic field. Those magnets are going to be spun by the spinning propellers. Sandwiched between the 2 magnet plates is going to be my stator plate. That's going to stay still, and on it, I'm going to have a series of 6 coils. As the magnets spin their magnetic field, hopefully they're going to generate electricity in those coils, wire them together, send them into rectifier to convert it into smooth 12 volts DC, then that can go on to charge the batteries for the guys in the hostel. Is that all right?
Absolutely brilliant.
Sensing that only face-to-face negotiations will work, Dick mounts his trusty biofueled steed. He needs those fire hoses. Failure is not an option. Jem's finished his wooden blades and has started on one of the 2 rotor plates which will eventually be attached to the magnets. In simple terms, 2 discs covered in magnets face one another and spin. In between is a static stator disc covered in wire coils. The spinning action generates an electrical charge. Because Jem will be drilling through solid steel, he needs to be absolutely certain that the holes are all in precisely the right place. This isn't a job that you want to do twice. Dick's powers of persuasion are plainly effective. The fire department have come to his rescue with enough ultra-strong piping to help him funnel the water down the mountainside.
Okay, do you know what the beauty about this is? It takes lots of pressure.
The heavy-duty fire hoses are ideal for the job. But carrying hundreds of kilograms of heavy pipe nearly a kilometre up through the rough terrain of the mountain is a daunting prospect. Getting his hand on the hose has made Dick a happy man. But with no transport, he's struggling to climb up the mountain with just one of these rolls. Even for an ex-army man, this is a really tough job. All he has to do now is get the water into the hose. But it's rather like hoping that air will just fill up a balloon by itself. It looks as though Dick's going to have to rethink this one.
There's not enough pressure to open this pipe. I need a rigid pipe.
After another SOS call, Tony has come up trumps again. He's rung around his friends in the valley and come up with some old drain pipes. By creating a small reservoir and then submerging rigid drain pipes into it, there should be no problem in getting water into the pipes.
Now the water's going to get rammed down the tube.
It means that whatever he attaches to the drain pipe should fill to capacity quickly. While Dick's playing around with water, Jem is racing ahead starting work on his generator. But how exactly will it work? With the 2 spinning rotor plates for his generator now cut, Jem needs a jig or stencil which will act as a guide to where the powerful magnets will sit on these plates.
Oh dear, mate. Making electricity?
No, Dick, far from it. I'm making a jig with the faint hope of making electricity in the future.
You got some problems there, mate. The spacing of your magnets, the spacing of your coils, the separation, air gaps are bad, you lose all of it. You know, that's not trivial.
Dick, why do you think I'm using all of this lot? I realise that getting it horribly accurate is the only way for it to work.
Whereas I've just got bigger hammers.
You enjoy yourself, Dick. The soft sound of me tapping on calculator buttons will almost certainly be masked by your use of large hammers. Nonetheless, Dick, shush, I can't concentrate. I'll get it right, don't worry.
The jig allows Jem to make sure that the 8 magnets are evenly and accurately spaced before being attached to steel, at which point, because of the huge forces involved, they become almost impossible to move. With the drain pipe fixed in place at the top of Sailberg, Dick still needs to funnel the water nearly a kilometre across a site of scientific interest, down to the River Lisa. Dick has got all the piping he needs, but absolutely no way of getting it to where it's needed. It's impossible for him to do alone, and a four-wheel drive is definitely out of the question. Defeat is now staring Colonel Dick in the face. With Jem's wind turbine nearly completed, Dick has 27 reels of heavy-duty fire hose waiting to be hauled up a mountain. He needs some serious reinforcements. While Jem seems delighted with his progress, Dick's in dire straits. But hostile manager Tony has hatched a rescue plan. He may not have rounded up the troops to help Dick, but it looks as though he may have called in the cavalry.
Tony said he had a solution. Is this it?
This is Thor and Prince.
Thor and Prince?
Yeah.
Are you sure that you can take those?
Oh, that's no problem. Two of those, no problem at all, and say 4 altogether.
4 in each pony?
Yeah,
So
I
we
mean,
take 8 at a time. Brilliant.
They used to carry 16 stones of lead and iron ore out of the fells down to the coast, so they're not going to be any weight at all. No.
In that case, we'll put 6 on. Oh, I was only joking.
Make it easy for ourselves.
Is this Prince?
This is Prince. We've got
Yeah,
to
only
lift
joking,
them on
Prince. Oh, yeah, he's quite frisky. Hey, this guy's that moustache.
now. He's got a moustache.
Let's get them loaded. These are heavier than the other ones. I feel guilty for Prince now. You know, we couldn't have done this. Carrying these things up the hill would have taken us days.
With Thor and Prince able to carry 91 kilos each trip, the number of journeys Dick needs to make has been drastically cut, allowing him to make drops of hosepipe all the way up the mountainside in just a couple of hours.
It's fairly flat, so...
Oh, Prince, that's so much lighter! Do you want to know something? Carrying those up here would have been a nightmare. Have you seen how far that is?
I know, it's fantastic, though.
I'll tell you what, I'm just going to take this one around the corner to the head, yeah? Away the
Come on,
workers.
boys.
See you down there.
See you now.
With a rigid drain pipe structure connected directly to the reservoir at the top of the mountain, Dick is now able to construct the entire 750-metre pipeline.
Get in there! Yes!
As he makes the final valve connection, the pressure begins to build. A key component of the water turbine is now in place. Any doubts Dick and Jem may have had about water supplies have disappeared. If Dick can make the water turbine work, it looks like there'll be no shortage of fuel. The hosepipe, which will eventually be buried to blend in with the landscape, is now laid all the way down to the River Lisa. However, if Dick can't control the raw power now trapped inside it, his water turbine could get blown to smithereens.
Just before you attach it to your turbine, check this.
OK, what have you done?
I have made a spud gun powered by mountains. That mountain up there lets the water run down your pipe. When you open that valve at the bottom, the water comes rushing in, crushes all the air in this tube into a space about that big. Then that air wants to explode. So when I open here, I let that high-pressure air explode into this pipe, sending a potato over that mountain.
You're joking.
A spud gun powered by mountains, Dick. It's the way forward. And if we get our aim right, we're having lamb for dinner. Chuck us up that rammer.
So what you got? You got a spud in there.
Yep.
I'm gonna let you take that metal bar out before I do anything.
Thank you.
You're not so scared.
Oh! It's gone off in my face. They're not supposed to do that.
So all the pressure from the top of that mountain is now going to go into this tube.
Yep.
Is this a clever thing to do?
I've simply no idea, Dick.
Here we go.
By releasing pressurized water into the barrel of the pipe, Dick has compressed the air in it, creating an explosive force. By shutting off the incoming water with his valve, Dick prevents water spurting out after Jem pulls the trigger.
You got pressure. Pressure in the hole, sir! Or do I need to hold this?
Yeah, I honestly just don't know what it's going to do.
Thank you, that really
Ready?
cheers me up. You ready? Give me a countdown. Okay.
1, 2, 3. What do you reckon? You're a military man, Dick. Is there a market for eco-munitions?
Do it again.
Yeah, okay. Go on then, Dick. Feel that? Oh, I love it.
Closed off, ready to fire.
Dick, this time I've put some moss in to make it look like mint sauce to really scare the sheep.
You ready? Here we go.
Ready?
Give me a
One.
countdown.
3, 2, 1. I can play with this all day.
Mate, I'm sorry. It's a lot of fun, but it's not making electricity, is it?
No.
Work.
Oh, okay. You just, one more go? Oh.
No more goes.
Having demonstrated that the high-pressure spud gun really is a hot potato, Dick realizes he must construct his water turbine to withstand immense forces. Getting it even slightly wrong could mean that his plan to bring electricity to Black Sail might end up as mash. It's now day 5. The clock is ticking. Jem must now focus all his energies on the alternator for his wind turbine. With all the magnets now in place on the 2 opposing spinning discs, he must now make the electrical coils over which the magnets will pass and generate electricity.
33.
This is tedious work, as each coil must be made from equal lengths of wire.
How long was that?
8 metres.
So you get 8 meters in 35 coils.
In theory, it should be possible to test if Jem can now generate electricity. By quickly passing a single magnet over a coil, some voltage should register.
OK, we'll have a competition so you can get the most voltage. All right?
Is there anything that's not a competition in your life?
Nothing. I think it's all one big competition. Ready? Nothing.
It's very vicious.
That surprised me.
Right,
But
okay,
that's
you hold it.
nothing,
You got it?
Yeah.
I'm going like that.
But there's no response. This is potentially disastrous, especially as it's not clear why no voltage is being generated. But with Jem now past the point of no return, he just has to hope that he's on the right track. The best way for Jem's electrical coils to stay fixed on the central stator disc is to embed them in fiberglass resin. This is toxic stuff and needs handling with care. And it'll be 2 hours before it's set.
Whoa. There we go.
We're liking this.
That's our stator. I've cast it as thin as I possibly can.
Good call,
So
good
that we've
call.
got the absolute minimum separation between our magnets.
That means we're going to get the magnets nice and close to the coils.
Yeah.
Good effort, mate. Well done.
Thank you.
With Dick's runner now complete, he has to figure out a way of directing the water at it. By creating a nozzle for the end of the fire hose, he can squeeze the huge jet of water through a tiny opening. This will concentrate the power of the mountain straight at the runner. With the water runner complete and the directional nozzle ready, Dick's keen to show off his handiwork.
Here, the water's going to be driving this around, supported on bearings. This is nice flexible coupling. Going to make electricity. And the nozzle sits here like this, yeah, at 60 degrees. The jet that comes out of there shoots 30 meters in a second. And that's going to be making this little bad boy spin. And remember, we get most of our power on the top, but we probably get about 40% of it on the bottom because it drives the top one, and then when it comes out, it drives the bottom one.
It gets
So
reflected back and hits the bottom one round.
yeah, because it's an impulse, so it's going to make the bottom turn.
When the water spurts over the runner, it will start spinning. This primary action creates 60% of the total energy produced. But as the water exits at the bottom of the runner, it gives it an extra kick. This secondary action produces the other 40% of the total power generated. But the forces at play here are truly remarkable. And Dick doesn't think that Jem truly appreciates just how much water pressure he has to control.
The pressure in here is phenomenal. All the water pushing off the mountain has meant that in here the pressure's about 5 times like you get in a lorry. It's huge.
Man, can we let it off now?
How far do you reckon it's going? How far do you reckon it's going to go?
I reckon it's going to go off like a fire hose, Dick, because it is a fire hose.
It's quite heavy, isn't it?
It is.
Right, mate.
Right.
Where do you reckon it's going to go to, Jem?
I think it's going to go just up to the trees.
Are you going to brace yourself?
I am. Okay, I'm ready.
Right, I'm holding tight, mate. Here we go.
3, 2, 1.
Oh, whoa! Whoa! Steady, Eddie.
That's amazing. That goes off.
After the water has dropped from Dick's reservoir up at Sailbeck, the pressure in the hose has reached 10 bar, the same as a submarine would withstand 100 meters below sea level. And if Dick hasn't built his water turbine to withstand such huge pressure, Jem thinks it might all end in tears. So he has a little surprise for
I
him.
wonder exactly how stupid it would be to try and harness that power with a wooden water wheel. And for that reason, I've built a wooden water wheel.
You're going to learn, mate. You're going to learn.
Dick, I've got to find out for myself. I've just got to.
Jem.
Now, I promise I'll try and hold on this time.
Are you ready?
Are you ready?
You brace yourself. Here we
ready?
go.
Coming on.
Whoa! Pay a point at it. Go on.
Come on.
Come on.
Come on, closer. Closer. Closer.
It's not...
Whoa. Oh. Oh.
Don't turn it off.
It keeps jerking me.
Don't turn it off. That's the wrong way. It's coming towards us. It's going the wrong way.
Well, that's made the point crystal clear. Back at the horse box, it's down to serious business.
Probably get ourselves an extra $500,000 there.
Jem and Dick now have to drop their rivalry. They need to put on a united front to assemble the wind turbine's
Okay,
generator.
that looks really great. Lock it off there, spin that up.
They must ensure that there are as few gaps as possible between all the moving parts to make the generator as efficient as possible.
It's that little knobble there.
That's tightened off. Spin again. Happy?
Oh,
It's nice
perfect.
and free running as well, isn't it? Okay.
That's lovely.
Next thing, mate, is that horrid one.
And now, the really tricky part.
Okay, let's get it in here. When these...
With one magnet rotor plate now in place and the coil stator on top, the second magnet rotor plate must be slowly lowered into position.
Oh, I'm feeling it now. I'm feeling it now. Okay.
With the two lots of very powerful magnets now trying to pull towards each other, Dick and Jem need enormous strength to avoid a nasty accident.
We gradually pull one out and then the other out. Okay?
Right.
So,
Mind your fingers at the edges, because...
it's all right, that's fine. I'm cool with that. Oh, that is getting heavy. Oh!
Is that your finger? That's cool.
All right.
Right.
Oh, that's gonna snap.
Okay.
Ready?
Yeah.
Right.
Oh, I don't like it.
Can you just tweak that up?
But after a few tense moments, Jem's electrical generator is complete. The magnets now spinning freely past the central stator plate and its coils. Standing by to generate electricity. With Dick's water turbine also nearing completion, he and Jem need to make sure that nothing has been forgotten.
I think about that stream full of water being directed through there, in there, hitting that. That is going to spin phenomenally. And I can easily see that having more power than a vacuum cleaner. And if it's got more power than a vacuum cleaner, that's as much as the whole hostel needs.
Yeah.
So I
haven't actually thought about a vacuum. Yeah, you're right. So we're talking about over 1,000 watts is what we're after,
Yeah.
and a vacuum cleaner. Right, that means if we're looking at this, I need to get protection on here, on the sides. But I'd quite fancy being able to see what's going on in there.
You've got that clear polycarb. If that
Right.
stuff's good enough for police riot shields, it's good enough for protecting this.
Okay, and then the final thing, I'll get those on, then the last thing I'm going to do is I'm going to weld this onto here, because that's our input, and that's us done.
I can't wait to see it go.
With protective sides and a connector pipe left to be added, the cross-flow water turbine is just about ready for action. The wind turbine is almost complete. The final stage is to weld the tail fin to the generator. The tail fin will keep the turbine's blades always pointing at the wind.
Right, blades on, blades on.
Dick and Jem are now ready to slot all the parts together.
Ooh, look at that.
Oh, yes. More willing attitude. Here we go, here we go, here we go.
Yes, that's nice and tight.
See, that one just loves going in. It's thriving on it.
Eventually, to Jem's evident relief, everything finally fits. The wind turbine has been Jem's personal cross to bear, but after 6 days of hard labour, he finally has the finishing line within his sights.
Oh, careful, careful, careful. Right. Yeah.
To address Tony's concerns about a wind turbine being a blot on the landscape, Jem has designed the whole thing to be collapsible. Now, Tony only needs to rig it up when conditions are favourable.
Steve, when it's high enough, we'll give you the shout and you start creeping forward. Is that okay? Cool. Right.
Steady!
Whoa!
Steady! Back a bit! Steady! Whoa! Whoa! Back, 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 back! Easy, easy, easy!
Okay. Easy. Whoa!
Jem! It's a wind turbine, mate!
2 car headlamps have been wired up to the turbine, which will hopefully light up as soon as the blade starts spinning. At last, everything's ready to go.
I'm overjoyed with the wind turbine, with the local weather conditions. The way that smoke rises up from that smokestack just does not please me at all. Even our ultra-professional wind turbine on there, that's probably actually not as good as the one we made, is not moving.
After spending almost an entire week battling the elements to create a wind turbine for Black Sail Hut, Jem could be forgiven for feeling that the world is against him. Our planet mechanic's stay in Ennerdale is virtually at an end, and Jem finds himself utterly at the mercy of the elements.
We've got no wind at all.
The future of Black Sail hangs in the balance.
Gusty. That's what it is, gusty and unreliable.
After a titanic effort, the Planet Mechanics hand-built wind turbine has been hoisted into position, ready to generate electricity. But with one tiny problem: no wind.
If ever something were to drive home to me how unreliable wind is, it's making the effort to build your own wind turbine and then watching it not go round. It borders on ridiculous.
Yeah, that is
Oh, when the wind blows!
But true to Ennerdale's wild and wacky weather patterns,
Yes, put your light, put the light, put the light in, put the light in.
things can often change in the blink of an eye.
Yes! Thank you! Look at that! That's going to be good enough for 80 or 100 watts. And that's on a day with no wind.
That is brilliant.
Imagine if it was windy.
While Jem has proved that a wind turbine will work, the weather is too erratic. Not only that, it's only generating 100 or so watts of electricity, far short of the 1,000 needed to save Black Sail. The future of the hostel is now in Dick's hands. True to form, the weather is up to its old tricks, but there can be no hiding indoors. This is Judgment Day.
Right, mate, so as far as I can see, the water part's all sealed. We have got control. We don't even get splashed. And when it turns, we'll be making electricity out this end.
I love your viewing windows. The main thing I think of, is it strong enough? So, yes.
Shall we find out?
Yes, let's go for it. All right.
With the water pipe down from Sailbeck happily pumping out hundreds of litres a minute, all Dick and Jem have to do now is connect it to the turbine.
Would have been nice if this was somewhere near the hostel.
Right. We've got enough water anyway.
Yep. More than we've got wind.
Looking good. Right, first things first, connecting this. I tell you what, do you want to take that end and I'll do the keying?
If I take this end up here, that's better. Can you give it one more key? Or maybe I will. Oh! Right, I'm just going to stick it on anyway. Oh, we have a laugh. We have a laugh.
this gently.
Okay, give me... I feel like... Whoa! Right.
Okay. So this is off, this is on.
Yeah.
If we have any emergencies, this is the one we open, all right?
Yeah.
So I'm very gradually going to build the pressure up. You ready?
The water is currently being diverted through a safety escape pipe. This must now be gently closed off to avoid a sudden explosive buildup of pressure before the main valve can be opened and the water funneled directly into the turbine.
So we're on full pressure.
Yeah, shall I get plugged in now?
Yeah.
I love doing these in the wet. Oh, right.
Right, now, mate, what we're going to do is we're going to open this up and the turbine is going to start to turn.
Okay.
And then what I want to do is when we get to 3,000 RPM, yeah,
Yep.
it'll be at 50 hertz, which is the right frequency to use. And then we'll see how much power we've got.
Yes. Right, I'm on my switching board.
Are you ready?
You're like a DJ.
Jem has constructed a basic diagnostic power board. If electricity is produced by the water turbine, the lamps on it will light up.
Yes, it's going, it's going, it's going, it's going, it's going.
We're making electricity.
You can hear that.
What are we on?
Press the hertz button, press the hertz button. I've got absolutely nothing
It's not going
coming
very
in.
fast. We're going to have more speed.
Hey, I've got a reading, 44 hertz.
Well, a little bit more.
That's close enough, that's close
Okay.
enough.
On one of them, wind up slowly. That's it. It's under load now.
Yeah, you got more back.
Hey, look at the light! Yes! Woo! A bit more.
All right, Dick, let's get the power to the people. Let's go.
A few hundred meters of electrical cable will transport a very green 240 volts of power across the river to Black Sail Hostel and a very hopeful Tony Hume.
Tony, electricity from the water turbine has now reached the youth hostel.
And with a little bit of help from the wind turbine, your job and Black Sail should be safe. Now hit the switches.
That deserves a drink.
Beers are on me.
Yeah!
Our Planet mechanics have proved that when Black Sail Hut finally loses its supply road and this whole valley is returned to nature, Jem's wind turbine can be an emergency life support, but so long as there's rain in Britain, then Dick's water turbine will churn out 1,000 watts every minute of every day and keep this much-loved hostel alive for generations of walkers in the years to come.